Hi everyone, this is Jonathan Cedillo, student at Grand Canyon University. Today I'm presenting to you Enhancement of Muscle Contraction. Presentation for the class Biology 515, Concepts of Human Physiology 1, Professor Sandra Barrera. The plant Eryobotria japonica, known as Loquat, has been attributed features that enhance muscle weakness, but studies need to be done to scientifically approve the effects people claim about this plant in muscle enhancement. The following paper presented, Loquat leaf extract enhances muscle contraction induced activation of protein synthesis signaling in rat skeletal muscle, investigates the properties of plant leaves in muscle enhancement and protein production of muscles. For this target, male Wistar's rats, 12 weeks old, were used for experimentation under Loquat leaf extract treatment. The control group was treated with water only. 1.5 grams per kilogram per day of local leaf extract was orally given to the experimental group of rats a day for 7 days. The same quantity of water was orally given to the control group a day for 7 days. On day 7, after 3 hours of ingestion of loquat leaf extract, the muscle gastrocnemius of the right leg in each rat was activated by electrical currents at 100 Hz in sets of 10 isomeric contractions of 7 seconds each stimulation with an interval of 3 seconds relaxation each set. After 3 minutes of rest, the following set of stimulation was applied. After set stimulations, the rats were sacrificed and the target muscle of both legs was put into a worked out activity. Phosphorylation of rapamycin complex 1 or mTOR1 and signaling pathways AKT, mTOR, and P70S6K were analyzed by Western blotting. Interestingly, the signaling pathway of AKT phosphorylation of serine 473 was not different in both groups, water treatment and leaf extract. The mTOR phosphorylation of serine 2448 shows the same results in both groups, but with an upregulation after electrical stimuli. On the other hand, the P70S6K phosphorylation of threonine 389 show upregulation after electrical stimuli in the extract treatment group compared to the water treatment group. These results suggest that the local leaf extract treatment enhances muscle contraction in the activation and upregulation of P70S6K phosphorylation of rat muscles. Introduction. 40% of human components are the skeletal muscles. These are critical for locomotion that allows physical activity and life quality. As humans get older, the strength in muscles is lost. Also, diseases can affect the activity of muscles such as sarcopenia and chronic kidney disease, muscle related. Therefore, it is important to maintain a healthy skeletal muscle system by developing therapies that fight against deteriorating muscle-related diseases. The mammalian target, rapamycin complex 1, or mTORC1, plays a critical role in the control of mRNA translation to initial muscle protein synthesis. Features of the mTORC1 pathway are important for the signaling of phosphainositide 3 kinase, or PI3K, AKT. Another important compound to the mTORC1 is the ribosomal protein S6 kinase or P70S6K, which helps in mRNA translation. Hence, mTORC1 signaling ATK, mTOR, and P70S6K is believed to be important in the mTORC1 activity and muscle protein synthesis. Many other plants are subject to be tested since people claim they help with muscle-related diseases such as Go Shajinki gan, Astragalus polysaccharides, and Astragali radix. The plant leaves of loquat or Eriobotra japonica have been attributed to helping with cough and nausea in several regions of the world. According to the authors of this paper, loquat leaf extract is a compound that can protect muscles from deterioration. In other studies, it has been demonstrated that the extract can block the dexamethasone-induced reduction in muscle activity in Sprague-Dawley rats. This is only advising that the leaf extract can prevent muscle atrophy. Improving muscle protein production and preventing muscle deterioration are important aspects to maintain muscle health. But the effects of the local leaf extract on the human body are still a mystery. When working out, muscle vitality increases due to the production of proteins needed to build new muscle tissue and replace the damaged muscles from the exercise. And this happens through the muscle protein synthesis of the mTORC1 signaling pathway. Authors of this paper claim that the mTORC1 signaling, AKT, mTOR, P70S6K, is improved by the consumption of loquat leaf extract. The hypothesis of this paper is that the loquat leaf extract and exercise enhance the mTORC1 signaling pathway. To prove this hypothesis, authors of the paper analyzed the effects of the leaf extract together with exercise in the mTORC1 signaling pathway in rat muscles. This will help us understand how the extract enhances muscle contraction-induced activation of protein synthesis. Material and methods. Loquat leaf extraction. The leaves of the plant were brought from Tokyo, Japan. 20 grams of leaves were converted into powder. Then they were placed in distilled water from 22 to 24 degrees Celsius for 30 minutes. The decoction of the leaves was done with a mesh filter using a centrifuge at 4,000 RPMs for 12 minutes at the previously mentioned temperatures. The supernatant was separated and put away at minus 80 degrees Celsius. The loquat leaf extract yield was about 0.25 grams per milliliter. High-performance liquid chromatography revealed the ursolic acid concentration, which was 17.6 milligrams per 100 milliliters of loquat leaf extract and zero point 0.4 milligrams per kilogram body weight per day. The animal models. 12 rats were acquired after the approval of the Juntendo University Animal Care Committee. These rats were divided into two groups of six. One group was given loquat leaf extract and the other group was given distilled water for a week. Also, the rats were exposed to 12 hours of light and dark each day. Their laboratory diet consisted of evidence-based complementary and alternative medicine. In the experimental group, the rats were given 1.5 grams per kilogram per day of the leaf extract. To the control group, the same amount of distilled water was administered. The administration of both compounds was orally applied using feeding needles under the light isoflurane anesthesia and one time a day for 7 days. Both groups were deprived of food 12 hours before the last day of their respective compound consumption. At the third hour of day 7, after ingesting their compounds, the rats were anesthetized and their right lower hind limb was shaved. Then the gastrocnemius muscle was stimulated. One of the electrodes was put at the knee joint and the other at the heel. Their feet were accommodated straight to stretch the muscle of interest. Then the pulsing current was applied at 100 Hz for 5 sets of 10 isomeric contractions of 7 seconds contraction, 3 seconds rest, and 3 minutes intervals for each set of stimulation. The rats were sacrificed and their gastrocnemius muscle was removed after 3 hours of the electrical current application of both groups. Removal of muscle. The rat's muscle was treated to be converted into powder. Protein concentration was measured using BCA assay. The proteins were separated by gel electrophoresis. The bands in the gel were quantified and the blots were stained to analyze equal protein loading. The information gathered was exported as mean standard deviation. The statistical results were performed with a two-way ANOVA followed by Turkey's post hoc test. Following and presented to you the results of the experimentation. The effects of local leaf extract and muscle contraction of the signaling pathway mTORC1, AKT, mTOR, and P70S6K are presented. In figure 1, the total phosphorylation of AKT is right here. And the right on top, we have the proteins that were phosphorylated at serine 473. We can see in the gel that the bands of the phosphorylated AKT serine 473 show protein production of approximately 60 kilodaltons of weight. The total protein was then stained by Ponsou's technique, which is right here, to confirm equal protein loading. On the right side, the values in both groups, control and experimental group, are presented as the mean of the standard deviation of the 6 rats per group, in which the p-value was 0.05. As an overall, for this particular pathway, despite the induction by the electrical stimulation of the rat muscle, the mTORC1 signaling pathway, the AKT phosphorylation in serum 473 was not stimulated by the electrical pulses. Here in figure 2, the activity of the leaf extract and muscle contraction are presented under the expression of the phosphorylation of mTOR serine 2448, right here. We can see in the gel that the bands of the phosphorylated mTOR serine 2448 show protein production of approximately 289 kilodaltons of weight. The protein was then stained by Ponshu-S technique to confirm equal protein loading. The values in both groups are presented as the mean of the standard deviation of the 6 rats per group, in which the p-value was 0.05 as well. Interestingly, with the electrical stimulation of the rat muscle, the mTORC1 signaling pathway at serine 2448 was upregulated due to the electrical stimulation. However, it shows no significant difference between the control group and the Loquat leaf extract targets. Here in figure 3, the activity of the leaf extract and muscle contraction are presented under the expression of the phosphorylation of the P70S6K threonine 389. We can see in the gel that the bands of the phosphorylated P70S6K threonine 389 show protein production of approximately 70 kilodaltons of weight. The protein was also stained by Ponshu-S technique to confirm equal protein loading. The values in both groups are presented as the means of the standard deviation of the 6 rats per group, in which the p-value was also 0.05. In this event, P70S6K phosphorylation at threonine 389 was upregulated after the electric current stimulation, in which this phosphorylation event at threonine 389 presented higher values in the leaf treatment group compared to the control group. In summary, the paper of interest is presenting the following. Results revealed that the leaf extract treatment did not have any activity toward the mTORC1 signaling pathway, but it did help in the muscle contraction-induced mTORC1 signaling by the stimulation of the P70S6K phosphorylation at threonine 389 in the muscles of rats. These data show that the loquat leaf extract addition did not improve the mTOR1 signaling pathway. However, it did enhance muscle contraction. Continuing, other data revealed that the leaf extract significantly enhanced the P70S6K phosphorylation at threonine 389, but it did not have a large effect on the AKT phosphorylation at serine 473 in contrast to the control group. However, in previous studies, the same phosphorylation of AKT was positively affected in vitro with loquat leaf extract treatment, suggesting that the effects of this treatment might be different in vitro and in vivo. Finally, results show that the loquat leaf extract treatment improves muscle contraction-induced activation of the P70S6K phosphorylation pathway at threonine 389 in rat skeletal muscles. Thank you for watching my presentation. See you next time.